Welcome to the another video of the basic electrical engineering. This is the second part of the video where we are discussing the numerical over here. Find the impedance, current, power and power factor of the following series circuit and draw the corresponding vector diagram. So R load, L load and C load, these three individual loads we have considered. RL load we have discussed. So we'll proceed from here. RC, RLC and LC. The value of RL and C is given here: 10 ohm, 50 millihenry, 100 microfarad. And the frequency is 50 Hz. Supply voltage is 200 volt. It means this is the RMS value. So let us solve it. So here the question is being formulated. So first thing is that impedance. So obviously the value of the Z is equals to R plus XJXC, or let R plus 1 by J omega L. We can write Z is equal to R minus JXC. This is also we can write. So this will be, because when J will go up, it will be J we can multiply on the top and the bottom. Then J square is minus 1. It will be like this. Now if we substitute the value of R as 10 plus, let us write this as minus of J 1 by omega is 2 pi 100 pi, because 2 pi into F, 2 into 50 is 100, into, this is not L, this is C. Capacitance is 100 10 to the power minus 6 Faraday. This, if we calculate, it will come out to be 10 minus J 31.83 in the rectangular form. We can write in the polar form as 33.36 angle minus 72.56. So we get the value of the impedance here, Z. Now the current will be equals to V by Z. That will give us 200 divided by 33.36 of this angle, and that gives us a value of the current is 5.99 angle of 72.56. This shows that the current is leading because it is positive angle. The voltage is of 0 and the current is leading. So the power is here is equals to BI star. We can write here 200 into 5.99 angle 72.56. This comes out to be 1199 of this angle, which we can write the real part of out of it. So P of real part, that is power dissipated in the resistor, is into cos of 72.56. That value is 359.36 watt. Now the cos of phi we can directly calculate from here, because of angle between voltage and current also 72 degree. So this will come out to be 0.3. that we call it lead, because the current is leading the voltage. So if we draw the phasor diagram, so when we draw the phasor diagram, we must draw some in the reference axis which is being flown through both the load. So let us take the reference as the current. Now whatever we will do with the current. So the next phasor will be current multiplied with the resistance will be IR, that is VR. So VR is the voltage across the resistor. So when the current is multiplied with the capacitor, it will be minus of J I by omega C. Negative J means it is in the negative y-axis. So minus of J I by omega C is the VC, voltage across the capacitor. Now the capacitive reactance is 31, resistance is 10. So comparatively resistance, whatever, let us bring this resistance value a little bit closer so that we map some actual picture. Let us say the current is here and IR is here. Now if IR, and now this is relatively, this is look I into 10, this is I into 31.8. Now if we draw the phasor diagram, phasor addition, we come out to be the resultant voltage as V, that is 200. Now the angle between them, V and I, is 72.56 degree. So usually in the question it is given that it is V angle 0. So one can say that this is my reference. He can again change and then say, oh, this is the current which is leading the voltage by an angle of 72.56. However, if we have the voltage, we cannot derive from the voltage the current. But if we have the current, we can derive the voltage out of the current. So this is case 5. Then we say case 6 is that when you have R, L and C together. Let us see that. So now we have the value of R, L and C here in series and the supply voltage is 200. So first we need to find the value of Z, that is R plus JXL minus JXC. So now we put the value here 10 plus J times of omega L minus J times of 1 by omega C. So we have already calculated this value, the impedance value, that is J times of 15.7 minus J times of 31.83. What we observe here, there is the two imaginary values. We can subtract them. And then after subtraction, what we can get is, we can get the value of Z is 10 minus J 16.13. It seems that the capacitive part is higher than the inductive part. The overall circuit becomes more capacitive. Is less capacitive because inductive part after cancelling the inductive part. And the real part, and let us write this in a polar form, that is 18.9297 angle of minus 58.2 degree. Now the current part of it is 200 by 18.97. This is, and this voltage is of angle 0. So now we get this value as 10.543 angle 58.2. This seems that the current is leading the voltage by an angle of 58.2 degree and the magnitude of the current is 10.543. So power is equal to VI star, which is equal to 200 into 10.543, this minus of 58.2. So that value will be 2108.6 of minus of 58.2. So we can write the real part and the imaginary part out of it. So the real power will be Vi, the total power cos of this value. This will come out to be 1111.13 watt. So the power factor also we can find is equal to real power divided by total power. That gives 0.527 lead. It is leading. So if we draw the phasor diagram, again we can draw the phasor diagram taking the reference as current axis. So the reference as current axis. So when you multiply I into R, we are somewhere here. When we multiply I into j omega L, we get the value of VL we have seen here, and we'll multiply I by minus ji in this one, I into j of xc, we get a negative value, that is Vc. So when we take the resultant will come here, this is Vc minus VL. This term is negative actually, that's why it is here. Now we have got a phasor addition we can do, and then we can write this is a voltage and the current is here, and the current is leading by an angle of 58.2 degree from the voltage. So this way we can find. Now if somebody will say that okay, voltage is the reference, then the current is leading with the reference to the voltage as this, but he has to start from the current. Last is the LNC. Let us do that. So here in the case 7 we just calculated the values, and the LNC value we put here, we get it a negative value minus j 16.13, this much ohms, and the current is V by Z, so it is in negative of minus j, so minus 90, minus of j, so it is minus of j is nothing but minus 90, and we get this current is, when it go up it will 90. So we get a current is leading. Obviously this is capacitive, overall it becomes a capacitive, so it is 90. So power is a Vi star, so that was the voltage multiplied with the current will give you this value, and this is star means a complex conjugate. So we get this term as minus of j 2479.8 watt. This much is the power value. So we get the power value as negative, so imaginary value. So real part is 0. So obviously the power factor is 0. So what is the observation that we have got from all this circuit is, this is RC load, and here you have the RLC. We get in RLC also this value here, the current is leading by positive value, and we get here the power as total power and minus of 58.2. So since in RLC it is more capacitive comparing the inductor and capacitance, so that is why we are getting a more capacitive part, and we are getting a minus of j. So this can be get in real and imaginary part, we get some P minus of JQ. So another one is that when we have real, only R and C was there. Again here we get current as positive leading, and then power is, this will be minus over here, and again this will be minus. So this will be, again we get it P minus J of Q. because here only capacitive is there. So even though we have R, L and C, wherever C is there, because capacitance is dominating, it is J31.83, the capacitance is dominating, we are getting a negative imaginary value. So when we have R and L, then you get a positive imaginary value, you get here P plus JQ. The reactive power is positive. So that also gives some information about the imaginary part J. It is negative or positive. Whenever the power, anything is positive, it is absorbed. When it is negative, it is delivered. So reactive power is also, it is absorbed if it is positive J. It is delivered when it is minus of J. So these are the few informations we get from adding L inductance, capacitance and taking a circuit with RLC. And for drawing the phasor diagram, so here again you need to draw the phasor diagram. So phasor diagram, again the current as reference. So here we can simply write VL as top one and VC as the bottom, and the difference is VC minus VL is negative part, and the current is there, so already. So current we have to take in the reference direction. With respect to the current, VL is positive J because it is J times of I into omega L, and with reference to current it is negative with minus of I by omega C, minus of J I by omega C, it is negative. Overall this term is getting negative because the dominance of the capacitance term, and we get the resultant voltage V here and the current here. Then current is leading the voltage by an angle of 90 degree, because in the question you have got the voltage is taken as a reference. Now current is leading the voltage. If you see that this voltage in the reference, the current is leading the voltage by an angle of 90 degree. So it takes time, but I think you have understood completely, and this help you to understand the difference in real power and active power, reactive power, and reactive power in the positive value and reactive power is a negative value. Whenever something is positive, it is absorbed by the load. Whenever something is negative, it is delivered by the load. My energy stored is feedback to the load. Thank you very much.